So what is Hurwitz stability criteria? Okay, so Hurwitz stability criteria, basically it's a method or mathematical method to know how many closed loop poles that are in the left half plane, how many are on the right half plane, and how many are in the imaginary axis. So let's say you have a transfer function that has denominator that is very difficult to factorize. So the example that I give you just now, most of the uh, transfer function is already factorized. So what happens if your transfer function, the denominator, is very long or very difficult to factorize? So you can use Hurwitz criteria without having to factorize your denominator. So in Hurwitz criteria, there are two steps in determining the stability. First, we generate the Routh table or the Hurwitz table. Secondly, we interpret the table. Okay, so let's look at the step by step on how to generate the table and how to interpret the table. Okay, so let's say you have a transfer function given like this. Okay, so you look at the denominator, a4 s to the power of 4 plus a3 times s to the power of 3 plus a2 times s squared plus a1s plus a naught. So let's say you have this transfer function. First, you need to generate the Routh table. So the first step to generate the Routh table is by looking at the highest power of your denominator. So here in this case is s to the power of 4. So your table must start with s to the power of 4. And then followed by s to the power of 3, power of 2, power of 1, and then power of 0. Okay? So table row starts with s to the power of 4 because this is the highest order or highest power of the denominator. Okay? After you draw the table with s to the power of 4 as the highest row, then you need to fill the two top rows alternatingly with the coefficients of denominator. So in this case, sorry. So in this case, you fill the two top row by the coefficient of the denominator. So first one is A4. So you put A4 here. And then the bottom one, you put A3. So alternate A4 and then A3. And then the next one, A2. And then the bottom one is A1. And then A0. And then for this one, because you don't have any more coefficient, then you just put 0. Okay, whenever you reach a point when you don't have any more coefficient, you just put 0. So here alternatingly means that you put A4 and then A3 and then A2 and then A1 and then A0. So you fill the two top row first. Okay, and then after you fill the two top row, then you can determine the values in the box for the remaining rows. So to determine the value of the S2, for example, you need to calculate determinants. So here you don't need to memorize the determinant, but you need to memorize how to determine the values inside the determinant. So for example, S2 here, you only take the 4 value of on top of the S2. For example, here you take A4, the determinant of A4, A3, A2, and A1, and then divided by the value of the box above S2. So here S3, A3. Okay, so you take the value of A4 and then A3, A2, A1, negative, divided by A3. So this is for the first box. For the second box, you take the top, the four top values above this box. So the value A4, A3, and then A0 and 0 here. Negative divided by A3. And then for this box, you take the same thing, the four values above this box. So you take A4, A3. So 0 here, basically you take the value here. So here there is no value. So you put 0 in this column. So no column here, meaning that you put 0. So 0 and then 0 here. Divided by A3 here. Okay. And then after you determine these rows, then you can determine the row S1. So for the row S1, the same thing, but you take the two top rows above S1. So the determinant of A3, B1, A1, B2 divided by B1. And for this box, you take A3, B1, 0, 0 divided by B1. And for this box, you take A3, B1, 0 here because nothing here, and 0 here because you have no values here. So you put 0, 0, and then divided by B1. Okay, then you get the values for the row S1. And then for the last row, the S0, do the same thing. So for the first box, you take value B1, C1, B2, and 0 divided by C1. For this box, you take B1, C1, 0, and 0 divided by C1. And for this box, you take B1, C1, and 0 value is here because there is no value here, and 0, and then divided by C1. Okay. Okay, so far so good ke dah tidur? Okay, so if you have any question, just ask. Okay, okay, boleh okay. So sorry. So this is the calculation method. So it may seem like difficult, but whenever you get you try the exercise later or the quiz later, you will get used to it. Okay, to in determining the right values for the determinant. So after you develop the Routh-Hurwitz table, then you need to determine the to interpret the table. So by to interpret the table, first you need to look at the number of sign changes in the first column. So the number of roots of the polynomial or denominator that are in the right half plane of the S plane can be determined by looking at the number of sign changes in the first column. If there are any sign changes in the first column, then the system is unstable. Sign changes meaning that, let's say if you have positive value here and negative value here. So positive to negative, there is one sign changes. So positive and negative means one sign changes. So one sign changes means one pole on the right hand side of the S plane. So let's say A3 and B1 here. Let's say A3 is negative and B1 is negative also. Then there is no sign changes. Means negative and negative, no sign changes from A3 to B1. So no sign changes means no poles on the right half plane. So you need to look at the first row column of the Routh table. Okay, so let's look at an example on how to use Hurwitz table for an example of case. Okay, so let's say you are given a block diagram as shown here. So here your forward transfer function is 1000 divided by s plus 2 times s plus 3 times s plus 5, and then you have a feedback. Unity feedback, so h equals 1 here. So first thing you need to do is to find the closed loop transfer function, meaning that you need to simplify the block diagram. So first simplify the block diagram. So the feedback formula is G divided by 1 plus G times H. Okay. So first simplify. So 1000. So this is the simplify. Okay. So 1000 divided by S plus 2 plus times S plus 3 plus times S plus 5 plus 1000. After you simplify, then you need to expand this multiplication so that you get a complete polynomial for the denominator. So you expand, so you get S cubed plus 10S squared plus 31S plus 1030. Okay, so you use the denominator to generate your Routh-Hurwitz table. So the first step is we develop a Routh-Hurwitz table by having the highest row as the S cube, because S cube is the highest order of the denominator, and then followed by S square, S1, and S0. And then the second step is to fill the two rows above of the Routh table by the coefficient of the denominator alternatingly. So first we put 1, okay, because the coefficient of S cube is 1. And then we put 10 here on the S square. Okay, so ignore this later. Later I will explain what is this, okay. And then 31, we put on this box. And then 1030, we put here. And then because you have no more values you can put, then you just put 0 on the remaining empty boxes, okay. After you fill the first two rows, then you can determine S1 by using the determinant. So first, you need to determine the values that you want to put in the determinant. So you put the value 1 here, or 1 and 1 here, 31 and 103 divided by 1. Okay, so here, before that, the second row here, you can simplify the second row by dividing by 10. You can simplify, or you can not. You can choose not to simplify. It will be the same values, okay. But here in the example, it chose to simplify the value for the values in the second row. So here it divides by 10 because you can factorize the value of tens from the value 10 here and 1030. But if you are confused with this simplification, you can just use the value 10 in this box, in this determinant, and the value 1030 in this determinant. It will produce the same value, okay. So the determinant here, you determine the values of the elements inside the determinant by taking the value 1 here, and then 1, 31, and 103 divided by 1, this one, okay. And then you get negative 72. And then for the second box, the value in this determinant is 1 here, this one, and then 0 and 0 divided by 1. So you get 0. And then for the last box, it's the value here, 1, 1, and 0 on this column. So no column here, so you put 0, and 0 here as well. So you get equal 0. So after you get the values in the first in the row S1, then you can determine the values for the row S0. Okay. So for the S0, you take the value 1 here, negative 72, this value, 103, and 0 here, divided by negative 72. Okay. Simplify, and then you get 103. And then the second box, you take this value 1, negative 72, 0, and 0 here. And then you get 0 values. And then the last one, you take the value 1 here, negative 72, 0 in this column, so no values, so 0, and then also 0 here, divided by negative 72, and then you will get 0. Okay. So after you determine, you completely fill the box, the Routh-Hurwitz table, then you need to look at the first column and see how many sign changes in the first column. So here, from S cubed to S squared, there is no sign changes, meaning that positive to positive, no sign changes. Then we look at the S squared to S1. So here, positive 1, and here is negative 72. So one sign changes here. There is sign changes here from positive to negative. So one sign changes. And we look at S1 to S0. So here negative 72, and here is 103. So here negative, and this is positive. So another sign change here, okay? So there are two sign changes. So whenever you have two sign changes in the first column, meaning that you have two poles on the right hand side of your S-plane. So whenever you have one sign changes or at least one sign changes, then the system will be unstable. Okay. Okay, so hopefully you understand for this part. Then for now, you can try to do quiz 9, question number 1. Okay, you can try to do it now. I give you maybe about 10 minutes. If you have any question, you can ask. Okay.
Saya nak tanya yang slide sebelum ni.
Slide sebelum ni. Ya. Yang ni ke?
Ini yang untuk kolom 2 tu, kolom 3, kenapa sama yang 1 0 1 0 yang sebelah tu?
Okay,
Kalau
ni
kolom pertama kan 1 atas kan.
Okay, so 1 0 ni. So 1 ni diambil dari value ni. 1 dalam S cube. Boleh nampak mouse tak? Mouse saya nampak. Okay kan? Okay, 1 ni diambil dari sini. 1 ni, yang 1 bawah dia diambil dekat bawah dia ni. 1 ni. And then 0 ni diambil 0 yang ni. 0 ni diambil 0 yang bawah dia pula. Okay, itu yang for this box. Meanwhile, for this box, diambil 1 yang sama. 1 ni dengan 1 yang ni. Tetapi 02 ni diambil dari 0 yang dekat kolom yang tak ada ni. Ada kolom kat sini tapi tak ada sebenarnya. Sebab tak perlulah kolom dah sebab dia kosong sebenarnya. Okay. So kolom ni kosong, tak ada value. So you just put 0 and 0. Okay, boleh faham?
Okay sir.
Sir.
Okay, ya. Yeah.
Okay, so yang pasal sign changes tu just kita untuk tahu pasal stable dengan unstable je kan?
Yes, for now kita nak tahu dia stable and unstable by looking at the sign changes. And also, kalau example ni tadi ada 2 sign changes. So 2 sign changes maknanya ada 2 poles on the right hand side.
Oh,
okay?
right.
So 2 poles on right hand side. So tadi bila ada poles on right hand side, meaning that dia unstable terus. Okay?
Okay, thank you sir.
Alright, any question? Okay, boleh try soalan quiz tu, try secara roughly lah, okay? Dalam kertas ke, kalau ada mana yang tak faham, boleh tanya, kita start balik 10.55, okay?
Asrudin, sila minta ajar.
Macam mana nak simplify tak reti tiba lagi. Soalan satu lah. Okay, soalan satu tu dia bagi TS, okay. Meaning that tak perlu buat block diagram simplification ke apa-apa lagi untuk soalan satu. Soalan satu just guna terus dia punya denominator, fill the box, fill the table, kira and then determine sign changes. Simple saja.
Oh maaf, tak perasan. Ingatkan dia dah bagi example lah. Rupanya. Oh.
Okay, yang merah tu clue, okay.
Okay.
Power perform suit.
Sir, ni soalan quiz yang kena submit hujung minggu tu ya, sir?
Ya betul. Kan dah buat sekarang, tak payah buat dah hujung minggu.
Ya Mirza, ya.
Oh. Zaim Sakri.
Ya Mirza ulang Ahmad.
Okay, video hari ni lupa nak rakam. Tadi kita baru rakam separuh jalan. So nanti section 3 punya lah saya rakam, insyaAllah. So jangan lupa subscribe YouTube. Aduh.
Malas, bising.
Asal tak ajak sekali baru meriah. Ajaklah. Lain kali saya ajak. Hidup. Ya.
Kalau S3 yang first column tu dapat kosong,
Ni boleh dapat kosong
yang quiz tu, kosong. Maknanya semua kosong, S2 pun kosong. Dia jadi bagi kosong.
Yang ni ke?
Yang first row.
Ah, ada kosong eh.
A
dapat kosong tu.
A itu dapat kosong.
A ni kosong?
Ha.
Mana boleh dapat kosong? Oh, boleh lah. But, oh my god, salah soalan. Damn
Betul.
it.
Kosong.
Jadi S2 pun bagi kosong jadi mirror tu.
Semua kosong tu.
Oh my
Mirror.
god.
Mirror.
Okay. Okay, soalan salah.
Kosong sir.
Ah?
Kosong.
Sir, Daim tu budak dekan.
Easy full mark, easy full mark.
Ajar. Okay, tak apa. Okay, tak apa. Nanti saya tukar soalan lain.
Patut bersyukur soalan ni.
Dia salah soalan yang kosong tu special case. Salah soalan kot.
Apa tu buat lah.
Tak apalah, nanti saya cari transfer function lain, okay?
Sir,
Ya.
saya rasa TS tu tidak selesai rasa.
Awak seorang je. Orang lain nak selesai.
Apa doh Lukman?
Daim boleh lah kau buat Google Meet untuk study group.
Okay, sorry guys. Saya nanti tukar soalan lain lah, okay? Terima kasih kerana memberitahu. Okay, so kita tengok, kita teruskan lecture, okay? Dapatlah negatif 4 tambah 4. Kosong lah, betul lah kan? Negatif 4 tambah 4. Kosong. Salah, okay? Dia kosong. Betul kan kosong kan? Apa-apalah, nanti saya tukar soalan lain. Okay, so we continue with our lecture. Alamak. Okay, so example number 2, now we have a gain K. Let's say you have a gain K on the transfer function, okay? So whenever you have gain K, then sometimes the question asks you to determine the range of K for the system to be stable, okay? So this is a famous question. You are given a gain K, and then you, by using Hurwitz table, find the range of K for the system to be stable. Okay, so here you have your transfer function TS tidak selesai, K divided by S cube plus 18S square plus 77S plus K. So first thing is to generate the table. So you have S cube as the highest power. So your top row is S cube, okay? And then followed by S square, S1 and S0. And then you alternatingly fill the 2 top rows. So the first box here is 1, and then alternate 18, and then 77, and then K here. Okay? And then you can determine S1 by determine the determinant. Okay? So ni dah skip lah. So basically you take the determinant of 1, 18, 77 and K. Okay, and then you simplify, divided by 18. Okay, so you must remember there is a negative in front. So negative 1, 18, 77 K. Simplify, you get 1386 minus K divided by 18. And then for the second box, so for the second box, because you will get the determinant of 1, 18, 0, and 0, meaning that you get 0. So you can put 0 here, or you can just leave it empty, okay? It's the same. It will be assumed as 0, okay? And then after that, you determine the row S naught. Okay, so for the row S naught, you take the value of 18, this value, 1386 minus K divided by 18, K and 0, and then put negative divided by this value here. So when you do all that, you will get K, okay? And then here, you take 18, this value, 0, and 0. So you will get 0 here. Okay, so you get this column in terms of K here. You have K in this S1 and S0. Okay, so how to determine the range of K for a stable system? So you know that for a stable system, the first column must have no sign changes. So no sign changes means the system is stable. If there is sign changes, means the system is unstable. So you need to check for all of these values in the first column to have positive value only. So here is positive, and here is positive already for positive 1 and positive 18. So this value here must be positive or bigger than 0. And then you simplify, you will get K less than 1386. Okay, so this is your first range. And then you need to look at the row number 4. Row number 4 here must also be positive. So K must be bigger than 0, positive. And then you combine these two range to get a combined range for K. So K must be between 0 and 1386 for the system to be stable. Okay, so for stable system, the first column must have no sign changes. Okay, and then from there you look at one by one to determine the values of K. Okay, boleh dapat? InsyaAllah boleh dapat. And then you can try question number 2 on the quiz 9. Okay, simple aja. Okay, so yang ni yang tadi yang ada orang dah laju sangat tu. So here you simplify the block diagram first. After you simplify the block diagram, then you use Hurwitz criteria, look at the first column, and then determine the value of K for each of the box. Okay, okay, boleh try. Kita sama balik 11:10 minit.
Zaim dah siap ke Zaim?
Dah quiz 3 dah meja.
Quiz 3.
Ha.
Ini quiz 9.
Sekarang dah quiz 9 Zaim. Waduh. Jauh.
Okay, boleh buat. Ada masalah? Okay, so soalan satu tadi tukar kat sini je. Jadikan dia positif, okay? Positive 4. I will send back to WhatsApp, okay? Okay, any question for question 9, question 2? Ke semua pergi makan?
Dah makan sih, dah makan.
Oh, makan laju
Saya tak yakin nak saya buat ni betul. Tak.
Tak apa, buat je. Macam tu lah exam nanti. Okay, so for question 2, you need to simplify. Alamak, ada orang call pula. Biar nanti lah. So for question 2, you need to simplify the block diagram. And then try to expand the denominator, okay? Hello? Waalaikumsalam. Ya, saya. Tak ambil sebab dah vetting yang baru. Sebab hari tu ada tambah set baru. Tak apalah, nanti saya ambil. Okay, alright. Okay, bye. Assalamualaikum. Okay, sorry about that. Okay, so after you simplify the block diagram, then you expand the denominator, okay? So maybe you have problem expanding the denominator because there are a lot of multiplication involved. But you have to expand, then from there you can determine the range of K. Kita apa buat je, nanti hantar, kita bincang, okay? Alright, so another example. Another example. Oh, dah tak ada example. Okay, habis dah sebenarnya. So after this you can do exercise number 3 pula. So exercise number 3 is a bit it's the same as exercise number 2, but you have more blocks in the block diagram. Okay, so usually for exam for test, sometimes we give you a block diagram yang complicated, and then we ask you to simplify the block diagram. After you simplify the block diagram, we give you some values, and then you determine the range of K. Sometimes determine the range of K, or sometimes determine the poles from the block diagram. So block diagram simplification is very important, although very hard, but try to understand how to do question number 3. So basically question number 3, it's still simple because these two boxes are in cascade form. So you just multiply these two together and then feedback with unity feedback. Okay. Okay, dah habis kelas untuk hari ni. Woo! So any question for this topic before kita boleh balik? Oh, semua senyap. Tidur lah tu.
Budak dekan tak nak tanya, budak dekan.
Dah dekan tanya apa lagi?
Budak dekan tengah study chapter lain.
Quiz 2 pula kot.
Quiz 1.
Dia quiz 3 tak submit lagi sir.
Itu tak payah submit lah, buang tu sampah je.
Funny lah Mirza ni, funny.
Okay, so try buat quiz ni, okay. And then tomorrow kita akan buat Hurwitz criteria for special cases, okay. And then kita bincang lagi quiz untuk quiz 10 pula. Okay, dah habis kelas. Assalamualaikum, bye-bye.
Thank you sir.
Okay, thank
Sir.
you.
Waalaikumsalam.
Waalaikumsalam.
Apa channel sir? Channel YouTube.
Apa?
Channel YouTube sir.
More sikit. Channel YouTube.
Naim mana Naim?
Ada. Channel YouTube entah. Muhammad Jamil.
Share link nanti kat dia.
Nanti saya share link.
Baik sir.
Ahmed X Gaming.
Kita buat stream main GTA.
Main game pun tak tahu.
Terima kasih.
Okay, bye. Jangan elok.